Okay, we're on.
Okay, perfect.
All right, so homework questions.
For me, I don't know. Maybe it's just me, but I like half the questions. I just couldn't even figure out what it was even asking. I understand like what the z-score is and how to find it, but for me, the questions just like they didn't even make sense.
Okay. All right, you you understand what the z-score is, Annie?
Yeah, and the formula and all that. I figured that out.
Okay. All right, so start us with a question.
Let me grab this. So let's see. So just like even number two,
Okay.
it says find the probability this randomly selected professional baseball player that'll have greater than 3.335.
Did you use the app?
Yeah, and I found the app, I guess, because I had to look at the answer key to figure out what the steps were that they wanted us to take to figure it out. Like, like, there wasn't enough information provided. Maybe it's just me, but
Okay. Um, let's see.
Sorry, guys. I keep going. I just exit something, so I'll
Sorry.
keep. Sorry.
Fine. Okay, so all right, I'm trying to find on the homework, Annie, where it kind of went over that. Okay, so I think it's like right under 3.1, isn't it? Where I mean, and the thing I think what was a little confusing is they give it to you in question two, but they don't really answer it till much further down in the lesson. Um,
maybe that was my confusion. Because, yeah, like trying to follow the reading and do the questions,
yeah,
it just didn't seem to quite match up.
yeah, it didn't. It didn't really match up this time. You're almost, yeah. I mean, because it says to do it as you're, going through, but it didn't really match up for part one anyway. But
Yeah.
so I answered the questions out of order myself. Number two was like the last one that I did. But let me see. Did they give us anything in number two, or do we have to look up that information? That how it worked? I can't even. Let me see if I can get my homework up here. Okay, here we go. All right. Find the player as a randomly selected professional baseball player will have a batting average that is greater than .335. Use the z-score and normal probability output to find the probability. Okay, so did you have then that the population mean was .261?
Yes.
Okay, you
But I
found
don't
that.
remember how I got that. I think I
They
got
they
it
gave
from the
it to us.
key.
They gave it to us, Annie.
Oh, okay.
Yeah, so that was. I mean, it was like at the very end of the lesson, but they did give it to us.
Okay.
And then the standard deviation was .034. And you got that. And again,
Yeah.
that was given to us. Those points were given to us.
Okay. So maybe I just had trouble finding where they gave that information to
Yeah,
us.
yeah. It was like I said. It was at the very end. There was a sheet we were supposed to open up called batting average.
Okay.
I think I may be getting that confused, but I think so. Is that right? Does that sound right, you guys? Uh,
Something like that, yeah.
okay, so we're given that information. Then you find the z-score off of that, and you don't have any trouble doing that. Is that right?
Yeah. It was
Okay.
easy to plug it into the formula and solve it.
Okay, so that was 2.1765. Then you're looking for the probability that he has a batting average that's greater than .335, right? So you're gonna go on to the app, the
Yeah.
probability applet, right?
Yeah.
Okay. And you're gonna put in a z-score of 2.1765. Right?
Yeah.
Okay, and then you're going to unshade everything that's to the left of 2.1765. Why is
Okay.
that?
Um,
And when you do that, you get .0148, and somewhere it said, we want you to understand that in this class you estimate to the third decimal place unless told otherwise. So I just estimated to .015. I don't know that they even did that in the homework, but that's what it said.
Okay.
Anyways, did you get it?
Yeah. So I got
Okay.
that.
Okay. So that one's okay?
Yes.
Okay. All right. So what else?
Well, I got the other ones. I mean, the ones where you just do the description and, say what the symbol stands for. Those were simple.
Right. Okay.
And let's see, number one, I plugged them into the formula and the way I kind of figured out, I did the Z formula, and then I just took the batting averages and plugged them into that spreadsheet that automatically found the mean and the standard deviation, and that's how I kind of plugged in those numbers.
Okay. All
I
right.
don't know if that was the correct way, but I did the unusual, not unusual, and kind of found the right answers, but
Okay.
again, it just kind of seemed like you had to go search for the information.
Yeah, you did. You did. You're right. It wasn't. They didn't do in an order thing. It was kind of random.
Okay.
Yeah. But you understand unusual is if I'm
More than 2 standard
right, greater than
deviations.
2
Yeah.
in either direction, and not unusual is less than 2. Everybody
Yes.
okay? Everybody okay on that, Bernice, Drew?
Can
Yeah.
you say that again? Sorry, the unusual. What did you say?
Yeah. So it's a Z score is considered unusual if it's greater than 2 in the positive direction or less than -2 in the negative. So if it's more than 2 standard deviations away,
Oh, okay.
that's considered unusual. Anything within that less than 2 standard deviations away is considered not unusual.
Oh, okay.
Because 95% of the data is within 2 standard deviations.
Right. Right.
The other 5% are uncommon, not desired. So they're unusual.
Right. Okay, so now I saw in part 2, you guys may have seen the directions said, I don't know if they've always been saying this, it seems like this is new, but that we're supposed to kind of go through this together. Didn't it say that? It's in the answer key, I'm pretty sure. It doesn't say that on the actual homework, but it did say it on the answer key.
Yeah, I saw that too.
Yeah. Somebody's at somebody's door. It sounds like.
It's not mine.
Okay. All right. So on number 6, they give us the mean score and the standard deviation. So it's just to fill in the blank on A. Okay.
Or Josh's.
Uh-oh.
He's downstairs for the He's got a better chance of at least being put down there.
Okay. All right. What proportion of the people who take the quantitative portion of the GRE will score above 165? So we're going to find a Z-score there, right?
Uh-huh.
Okay, so we just take 165, subtract 150.8, and then that quantity is going to be divided by 8.8. I got 1.6136.
Yes.
Okay. All right, so then I just plugged it into the app and looked at the shaded area to the right because we're talking about greater than. And I got 0.053. Is that what everybody got? Or 5.3% approximately.
Mm-hmm.
Yeah.
Okay. All right. On C, if a student scores in the 10th percentile, what would their corresponding Z-score be? So you just go straight to the app and you're going to put 0.10 at the top, right, for the percentile. And then the corresponding Z-score I got was negative 1.282. Everybody okay with that?
I'm
Yeah.
following along.
Questions there? Any questions?
No, I think that's right.
Okay. And then on D, what is the quantitative GRE score for a student who scores, I'm sorry, we just did that, right? Oh, okay, so we didn't finish it. Did we finish it? Never mind, just kidding. What is the quantitative GRE score for a student who scores in the 10th percentile? Okay, so I just plugged it into my z-score equation. So I let the z-score be negative 1.282, which we just found in C. And that's going to equal x, my data point, what I'm looking for. Subtract the mean population over the standard deviation, and then solve for x.
Yeah.
Okay, and so x equaled 139.5818, so that's approximately 140 GRE score.
Yeah. That's what I got.
Okay, Bernice, Drew, is that okay?
Right.
Yeah. Okay. All right. So then 7A, at room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of, they gave it to us, right? So it's just filling in the blank, 1,800 meters per second, and the standard deviation is 600 meters per second. What is the probability that a randomly selected particle has a speed over 2,500 meters per second? So then we're going to find the z-score, right?
Yeah.
Which is 1.1667. Plug it into your app, and the probability is 0.1217.
Yes.
Okay. And then, so then the probability that it's less than is going to be 1 minus 0.1217. You can do it that way, or you could have done it a different way. You could have looked at the shaded area to the left, but it's 0.8783.
Uh-huh.
Okay. All right, part D, probability that a randomly selected particle has a speed less than, oh wait, we already did, or sorry, less than 1,500 meters per second. So you're just going to plug in 1,500. For the z-score, you get negative 1/2. Plug it into your app. 0.309 was the probability there. Yeah?
Yeah, 1,500.
Mm-hmm.
Okay. And then E was probably the randomly selected particle has a speed that's between the two. So I took the probability that it was less than 2,500 meters per second and subtracted off the probability that it was less than 1,500 meters per second. So that would be the in-between part, right?
Yeah.
So that gave us, what, 0.5698? Is that right?
0.5698, yeah.
Okay. And then F, what is the third quartile of the speeds of hydrogen at room temperature? So plugged in 75 up into that top box, the percentile. Right? I'm pretty sure that's what I did. And I got a z-score. And so then with the z-score, I plugged it into our z-score equation. So the z-score was 0.674. That's equal to x minus 1,800 over 600. And I got that the speeds were 2204.4. Any problems with that question? No?
Mm-mm.
Go girls. Good. Okay. All right, so then the QQ plots. Now those I got C wrong. It still looks to me like it's not quite linear, but they said it's linear enough. But if C is linear enough, then it seems like E would be linear enough, so I don't quite have those. I mean, I guess I can kind of see, but it seems like a little bit of guessing to me. Anybody have any input there? Does anybody else make a mistake there, or does everybody else see it?
Which plot?
The B.
Well, plot C, I didn't think it looked linear enough, but they said it is.
I can kind of see it.
Yeah. Yeah, but then plot E, they say, is not linear, which it looks close to me, close enough to plot C. So anyways, I mean, I guess I kind of get it. There is kind of a definite curve in plot E, whereas plot C kind of like, there's some curvature, but it continues,
in the same
throughout.
with the E, it seems like it gives two kinds of slopes. With the downward slope, it kind of points more upward.
Yeah.
Further over the right goes in the other direction. That's why it's
Right.
not normal. Whereas with C, it's kind of in the same direction, the same line, even though it's kind of jagged.
Okay.
Oh, I know what you're saying. Hmm.
All right. Well, do we think we're ready to quiz?
Let's do it.
Okay.
Go for the gold.
Okay, we're going to be using the normal probability applet. So does everybody have that up, or can they get it up before we open up this quiz?
I have it on.
Okay.
I've got it up.
I do too. Okay. All right.
Fired.
Okay. Total area under a density curve must equal.
One.
1.
Right. Right. Under certain circumstances, a density curve can drop below the x-axis.
No.
A normal density curve is symmetric.
True.
True.
Yeah.
Use the following image to answer questions 6 and 7. Which of the following elements of the figure represent the z-score in this image? C, right?
B.
I have C. C would represent the z-score.
Yeah, I think it's C.
Yeah.
Oh, yeah.
Uh-huh.
Which of the following elements of the figure represents the probability that the z-score will be greater than 1? That's the B, the shaded area.
Yeah.
Okay. I don't know.
According to the 68, 95, 97.99.7 rule, what proportion of the data from a bell-shaped distribution will be within 1 standard deviation of the mean?
68%.
Okay.
Suppose that 68. Everybody got 68?
Yeah.
Okay. Suppose that the z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Shouldn't it just be 68?
That's what I thought.
0.6827. What do they want it normal, good to 3 decimal places, somebody said?
There's 3. Yeah, there's 3.
So it would be 0.683. Is that what you guys got?
Yeah.
683.
Interesting question.
Okay.
I guess this is where I get lost. Like, what are we putting into there? Are we just putting in 1 into the applet, or
Yes. So down to those bottom 2 boxes there, Annie.
Yeah.
Go to the right one and just write 1.
Oh, okay, never mind. I figured it out. I didn't have the right area shaded. Okay.
Oh, okay.
I had the one above. Okay. Never mind. Now I got 0.6827. Okay.
Okay.
Sorry. I got that now.
Suppose that the z-scores
So keep it at 0.682 or
0.683. You would round up there because that next number's 7.
Oh, okay. Okay.
Suppose the z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2? Okay, it should be really close to 95.
Yeah, I got 0.955.
Okay. Yes, 0.955, that's what I've got. Too. This is funny. Okay, so he's just proving a point here, it looks like to me.
Yeah.
Oh, that makes sense.
All right, 0.997.
Yeah, look at number 12. It's exactly what it's asking.
Carefully answers the last two questions. What do you observe? The values match the 68, 95, 99.7 rule.
Yes.
As these area between negatives and z decreases. No.
0.99.
Okay.
Okay.
I can't find my calculator now. And I need it.
So just make sure I'm doing this right. We find the z-score, and then plug that into the applet, correct?
Got it.
Okay.
All right, Annie, did you get 0.1957?
Yes, I did.
Okay. Is that what everybody got?
1597.
0.19.
Oh, less than. Okay, that's right. Yeah, I got it. It's looking at
Okay.
the middle.
So we're gonna round that to 0.196.
Yeah.
Yeah, let's do that. Same thing, but more than. So we could do the same thing for 14, wouldn't it?
What have you guys got for 14?
It should be the same answer, shouldn't it?
Well, it's more than.
Yeah,
So
you
we
just
were looking at,
move it over instead.
right, so we're going to look at the, so it should be 1 subtract number 13.
Is it?
In other words, 0.804. We're looking at the right side now.
Oh, okay, I forgot the middle. That's right. So, 184, 804. Yeah.
Okay.
So I guess I did that one 'cause for number 14, I got this same 0.196.
Okay, well, we're looking at even the middle there, Annie.
Yeah, you gotta use the
Okay.
middle.
Through
So you
two.
said it's just 1 minus
Right, that's right.
the 0.804?
Mhm.
Yeah.
Okay.
Less than. Okay, we got a new number. 0.716.
Hey, Drew, I think I heard you say what I got, 0.716?
Yep.
Okay. And then I'm guessing they're going to do an in-between one, which looks like they are. Okay, so we're just going to take 0.716 and we're going to subtract off the 0.196, right? Sure.
That sounds right. I'm just looking at the problem. I guess that's a way of doing it faster. Yeah.
Mm.
You did that, it'd be 0.5 too.
Yep, that's what I got too. Everybody there?
0.52, you said?
Yeah.
I got that.
Okay.
I'm slow, sorry.
So take your time and ask questions if you have them.
Okay.
All right. How are we doing on number 17? Anybody got that yet?
No.
I'm sad to say I have no idea how to even figure out 17 and 18.
That's okay. Okay, so what you're going to do is put 35 in that top box, Andy, because that's the percentile that we're looking at. So you're going to put 0.35 in the area.
Oh, so you're just specifying, you're kind of doing it kind of backwards, I guess.
Exactly.
Okay.
You'll then get a z-score, negative 0.38. Okay? You're going to plug that z-score into your z-score equation.
Okay.
So negative 0.38 is equal to x minus 0.66, all divided by 0.07. And you're going to solve for x.
Can you repeat that again? You said we get a 0.38 negative.
Uh-huh. Yep. And so then you're going to plug it into your z-score equation, Bernice.
Okay.
You'll have negative 0.38 is equal to x, subtract 0.66, that mean, right, that we were given, all divided by 0.07, the standard deviation that we were given.
Oh, okay. Oh, you're so smart. Okay.
would expect the 35th percentile to be a little bit below the mean. The mean is 0.66. Our answer should be below 0.66. We do it right.
Yeah, mine's just a little bit below.
Okay, what did you get?
0.633.
That's what I got too. We're going to do the same thing with number 18.
Okay.
Drew, does this sound right?
Sure. I hope. Let's see.
Yeah, I hope too. I'm going to go back to my homework and just make sure that's how we did it before. Anybody finish that last one?
Yeah, I got 0.719.
So I got too many. I'm just checking with the homework and making sure that I feel pretty confident that that's how we did it. Yeah. That's how we did it before, so should be right. Okay, let's just real quickly review what we wrote and make sure everybody's okay.
Okay.
Number 3, we have 1. The total area is 1. Underneath.
Mhm.
Number 4, a density curve is not going to drop below the x-axis, so we have that as false. That would give us a negative area, which would never happen. Number 5, a normal density curve is symmetric, true. Number 6, we have C is the z-score in this image. That's where we plug in the z-score, so that's the z-score. 7, a z-score greater than 1 would be the B area. Okay. Number 8, we have 68%.
Yeah.
Yeah.
Must be of the data. 68%. Okay, that's a percentage. Good. I was going to say. Okay. So the z-score comes from student number. Okay, 0.683 for number 9.
Oh, sorry, what did you say?
Yes.
For number 9, 0.683.
Oh, yeah, yeah.
Okay. Number 10, 0.955.
Yes.
And 11.997. Okay. Number 12, the very first answer, the values match the 68, 95, 99.7 rule.
Yes.
Yeah.
Number 13, 0.196.
Yes.
Yeah.
14.804. Okay. 15.716.
Yes.
16.
I'm sorry, can you repeat 15?
Sure. 0.716.
Oh, yeah, okay.
Number 16.52.
Yes.
number 17.633,
Mm-hmm.
and number 18.719.
Yes.
All right. Anybody brave enough to submit it?
I got 100%.
All right. Yay.
Okay. Cool.
Okay, so we're on for Thursday.
Yeah.
Yes.
Or
Did anybody try to access this material before noon today? Was it accessible before noon today? You guys know?
Well, yeah, lesson 5 was.
yeah,
It was. Okay, so
I was looking at it last Thursday.
you were. Okay. Okay, so maybe he just posted the whole week's lesson at a certain on
Yeah, on Thursday.
Okay. All right. Well, hopefully, I don't know if lesson 6 is going to be available yet. Should we check on that?
Let me see what it says.
Yeah, this
It opens up 1 day in 15 hours, so it's
It-
probably going to be Thursday at noon again.
It is. How is that for everybody then?
For me, it's good.
It works for me.
Works for me.
Okay, great. Then we'll go for it. Okay, we will see you Thursday at 8:15.
Perfect.
Okay, thanks, guys.
Mhm.
Have a good night.
You too.